Now, artificial intelligence is a really big, popular topic. You're hearing about it everywhere. In case, just to dial it back and make sure everybody's on the same page, AI is artificial intelligence. So, if you ever hear anybody talking about AI, they're talking about artificial intelligence. So, what is artificial intelligence? What does it mean? Why are we hearing so much about it now? People used to talk about artificial intelligence all the time back in the 80s and 90s, and there was there's the Terminator movies, and there's a bunch of other movies about AI taking over the world, killing everybody, getting rid of human beings, and ushering in a new era of robot overlords. And that's a really popular idea behind artificial intelligence. And who knows, might not be far from the truth. But what's happened in the last couple of years that's made artificial intelligence so popular? Well, let's take a step back. Let's talk about the way that computers operate and the way that software is developed. Many years ago, in ancient history, all the way back to the 70s, the 1970s, that's right, when your parents and grandparents were alive, if you're a younger generation, there was a time of bell bottoms and big poofy haircuts and big hair and everything called the 70s. And in those times, that's when a lot of basic computer research was done. And there was a lot of discussion at the time over how computers should be programmed and developed. And there were basically two models. One model was data driven, and the other model was expert driven. So the idea was you would have the expert driven model is you would have domain experts that would define what was important about a field, figure out algorithms, use those algorithms to develop programs, applications that would then be used to achieve particular goals. The other idea was to use data driven algorithms. So you would feed the data into a computer. The computer would digest that data, and then get trained on it. So a human would train using the data, and then the computer would develop its own algorithm. Now, the expert model won out. Part of that is because it was more understandable, it made more sense, but also because the data-driven algorithm was way more computationally complicated. So experts could design very small, efficient algorithms that would work pretty well, whereas the data-driven model required tons and tons of data, and it just wasn't a realistic model to use at that time because memory was super expensive. I mean, we're talking about the days when 64 kilobytes was a lot of memory, and there's nowhere near enough information in 64 kilobytes to be able to train a system on how to operate. Now, of course, things have changed. Things have changed quite a bit. So now we get into the situation that we're in today when you can have petabytes and petabytes of data, and those petabytes and petabytes of data can then be trained, can be used to train machines. And that's the world that we're in today. And that's exactly what's been happening. Over the past 10, 15 years or so, there's been gigantic leaps. And of course, there's this whole idea, what's called the singularity, when AI becomes so smart that it's able to program itself because it's smarter than the humans that are using it. And we're starting to get to that point. It's kind of a science fiction-y concept. I'm not going to get into that kind of stuff because that kind of gets into a weird conspiracy theory type world. But just to give you an idea of what that would mean, let's take the game of chess. So you program in, so artificial intelligence is you would program in, some very basic rules, and then you would have the computer, rather than programming in algorithms for the computer to follow, which, algorithm is basically just if this, then that. So the expert-driven model is you would take a bunch of chess experts, you would show them a bunch of these, and then you would design a set of rules, those are algorithms, and you would say if this, then that, if this, then that, if this, then that. You would give that to the computer, you would have a programmer program those algorithms out, and then he would play a game against an expert, and then follow that. Now, the data-driven model, which is the AI model, uses a very basic set of rules, like this piece can move here, this piece can move here, and then it just plays game after game after game after game after game with human beings. And then as it plays those games, it's able to learn based on those data sets. So it learns, if I move this piece here, then I'll lose this piece to that. So don't do that again. If I move this piece here, and then it compounds and compounds and compounds. Now, of course, that takes hours and hours and hours and hours and hours and hours. But what's cool is what they're starting to do now is they'll have a computer train with a human. Once the computer gets smart enough with the human, then they'll have that computer train another computer. And then once those, kind of reach a point of stalemate, then they'll have the human play against the computer that was trained by the computer. So then that's where you're getting into the singularity point. There will be, conceptually, there will be this idea where the computers will eventually become so good that only computers can beat computers. And that's the whole idea. Now, all of this is achieved through what's called an artificial neural network, which basically weighs they're basically, what's the right way to think about this? They're functions that weigh percentages of prediction. So they take an input, they take an output, and they figure out in between there what's the chance that this input matches that output. So, for example, they see a picture of a cat, and they, based on all of the identifiers that they're able to make, they say, well, there's a 90% chance this is a cat, and that's the answer. So they're able to scan the image, look through the image, and it's actually more complicated. It's not a neuron. It's a neurological network. So all of the neurons scan the image. All of them come to their own ideas, and then they all weigh together. And that's also what's called machine learning. All of this is a subset of what's called machine learning. Machine learning is, again, that's that data-driven technology. So that's the machine will be given a data set. You give it 1,000 pictures of cats. All of the different artificial neurons weigh what they think the percentages of that cat, and then you tell them at the end, this is a cat or this is not a cat, and then it learns. In other words, you don't tell it, how do you tell the difference between a cat and a dog? You just give it the data and say, cat, yes, cat, yes, no, this one's not a cat. And then it determines, it'll be able to determine, by adjusting those functions, it'll be able to determine whether or not that is in fact a cat by learning on the machine level. In other words, the human's not giving it an algorithm that it's following. It's giving it data, and then the neurons are interpreting that data, and then the human is either telling them it's right or it's wrong. If it's wrong, then it adjusts those functions accordingly, and given enough data, then it's able to learn the difference between different things. All of this is part of a process that's called deep learning, which is in a lot of ways just a form of statistical analysis. And that's really what you're running into with all of this stuff. It's a statistical pattern recognition system built up, again, of these artificial neurons, which, again, neuron is all it is a function, a predictive function. What's the chances that this is a cat? What's the chances that this move on this chessboard will result in me losing the game? That stretches over time. So some neurons will have different predictions, and then that deep learning process will take in all of those neurons and come up with a predictive analysis at the end that it can use to make decisions. That's totally different than algorithmic programming, where an expert comes in and just simply says, if this, then that. So that's the fundamental concept between what we're talking about today with artificial intelligence. It's really just machine learning, deep learning. It's really just predictive functionality, all developing programming that is then used to create outputs. Obviously, that technique has been applied to a lot of different things, like predictive text and producing images and all these kinds of things. But fundamentally, That's the concept at use when people are saying artificial intelligence. So I wouldn't say it's a misnomer. It's a subset of artificial intelligence, because really all artificial intelligence is a system where the computer makes the decisions by itself. And so this process, this deep learning process, is a subset of that. But it's not the same as an actual intelligence that humans possess, which is a generalized intelligence, which is an entirely different subject.